Hi everyone. In this video, we're going to look at how to evaluate trig ratios. To help us evaluate trig ratios, we can use special triangles. Now remember, special triangles can be used to find the value of trig ratios for some angles measured in degrees. But what if we wanted to find the trig ratio for an angle measured in radians? How could we do that? Well, we can convert our angles in degrees in our special triangles to radians. Let's do that. Okay, 45 degrees. Now remember, pi radians is 180 degrees. 45 degrees is 1/4 of 180 degrees. And since pi radians is 180 degrees, 45 degrees is going to be pi over 4. Okay, on the right here, 30 degrees. 30 degrees is 1/6 of 180 degrees. And since pi radians is 180 degrees, that means 30 degrees is going to be pi over 6 radians. And 60 degrees, that's 1/3 of 180 degrees. So 60 degrees is the same thing as pi over 3 radians. And there we have it. Now we have our special triangles in terms of radians. And here they are, just with the angles in radians by themselves. Now, we're going to use those special triangles to help us find the exact value of some trigonometric ratios. Let's start with this example right here. Sine of pi over 6, cosine pi over 6, and tan pi over 6. To help us out, I'm going to consider a circle here. And I'm going to draw my angle pi over 6 along this circle. Okay, well, pi over 6, that has to be somewhere between 0 and pi over 2 radians. And actually, pi over 6 is going to be 1/3 of pi over 2 radians, right? So my angle pi over 6 is going to be this. Since this is 1/3 of pi over 2. What I'm going to do now is I'm going to place my special triangle here on my circle. And we can use this now to find the sine, cosine, and tan of my angle pi over 6. Let's start with sine. Okay, sine, remember, is opposite over hypotenuse. The opposite side of my triangle, that's 1. And this is the y value. This represents the y value, right? Because it's going up and down. My hypotenuse, that's the radius of my circle here. So, we can represent that with the letter r. So, my radius r is 2, my y value is 1. So if I plug this in, sine of pi over 6 is going to be y over r, or 1 over 2. Okay, cosine. Well, cosine is adjacent over hypotenuse. My adjacent side here, square root of 3, that represents my x value. And my hypotenuse here, that's the radius of my circle. That represents my r value. So we can say cosine pi over 6 is equal to x over r, or root 3 over 2. Okay, last one, tan of pi over 6. Again, we know tan is opposite over adjacent. The opposite side represents my y value, and the adjacent side represents my x value. So, tan of pi over 6 is equal to y over x, or in this case, it's equal to 1 over the square root of 3. Let's take a look at another example. Say I wanted to find sine 3 pi over 4, cosine 3 pi over 4, and tan 3 pi over 4. Again, we're going to start by drawing out our angle on our circle, along our circle. Okay, 3 pi over 4. That's going to be between pi over 2 and pi radians. And actually, it's going to be halfway between pi over 2 and pi radians. So, this is going to be our angle. Now, just like before, I'm going to use one of my special triangles to help me find these trig ratios. I'm going to try using this special triangle. If I rotate my special triangle here, and place it on the circle like this, again, now you'll notice my special triangle is along this angle. So, I can now use my special triangle to find the sine, cosine, and tan of my angle. And it can be helpful to label your sides, right? Label your x value, label your y value, and label your radius r. Okay, my x value, well, we can see here that the length of this side is equal to 1, right? And this side right here is on the negative x-axis. So we can say x is equal to negative 1. My opposite side here has a length of 1. And this is on the positive y-axis. So we can say y is equal to 1. And the radius of my circle, well, the radius is just the square root of 2. Now, something I want to note, the radius of your circle always has to be positive. Okay. Now that we've identified those sides, now we just have to plug it in to our formulas for sine, cosine, and tan. We saw from the previous example the sine is equal to y over r. So if we plug those values in that we have, that's going to be equal to 1 over the square root of 2. Cosine, we saw, was equal to x over r. And if we plug our values in, we get negative 1 over the square root of 2. And tan is equal to y over x. So again, if we plug our values in, we get 1 over negative 1, which is just equal to negative 1. Okay, what if I didn't give you this circle? What would you do then? Well, you would do the same thing. right? You just have to draw it out now. Okay, cosine 2 pi over 3. Let's draw out our angle. Okay, so if we consider this, so this right here is going to be 0 radians. This is pi over 2 radians. And this is pi radians. Okay, 2 pi over 3, that's going to be somewhere between pi over 2 and pi radians. So I'm going to draw my angle right here. Now what we're going to have to do is we're going to need to draw a triangle from the x-axis. And now all we need to do is we need to figure out what this angle here is so that we know which special triangle to use. Well, if this is 2 pi over 3, well then what we need to figure out is what does this angle have to be so that when we add it to 2 pi over 3, we get pi. Well, if you're not sure, well, you can try subtracting 2 pi over 3 from pi to see what angle this has to be. Okay, we want to rewrite this so that they both have a common denominator. Right, 3 pi over 3 is the same thing as pi. Now, 3 pi over 3 minus 2 pi over 3 is 1 pi over 3. So, this angle has to be pi over 3. And now we can use one of our special triangles to help us label the sides. If you look at this special triangle right here, we can see the side across from pi over 3 is equal to the square root of 3. Okay, that will be our y value. The side adjacent to our angle pi over 3 is 1. And since this is on the negative x-axis, x is going to be equal to -1. And our radius is, our hypotenuse here is 2. That's our r value. And now we can just plug these in to our formula for cosine, which remember is equal to x over r. Okay, if we plug our values in, there's our answer. Okay, last example. Tan of 7 pi over 6. Again, I'm going to start by drawing out my angle. Now I know, 7 pi over 6. I should draw my angle between pi and 3 pi over 2. Because 7 pi over 6 is between pi and 3 pi over 2. Okay, let me draw a better line there. Okay, so there's my angle, 7 pi over 6. Now, I'm going to draw my triangle from the x-axis like that. And now, to figure out which special triangle I have to use, what I'm going to do is I'm going to have to figure out what this angle is. Well, in order to figure out what this angle is, we need to figure out how much bigger is this angle, 7 pi over 6, compared to pi. And to do that, I can just subtract 7 pi over 6 by pi. Again, I want to rewrite these so they have a common denominator. 7 pi over 6 minus 6 pi over 6 is pi over 6. And now I can use this special triangle with the angle pi over 6 to help me label my sides. The side adjacent to pi over 6 has a length of square root of 3. And since this is on the negative x-axis, x is going to be equal to negative square root of 3. The side opposite to my angle pi over 6 is 1. And since this is on the negative y-axis, y is equal to negative 1. And my radius here is 2. Again, remember, the radius always has to be positive. And now, if I use my formula, y over x, well, if I use my formula there, okay, y, that's equal to negative 1, and x is negative square root of 3. Negative divided by negative, that turns into a positive. So my answer here is 1 over the square root of 3. So again, to evaluate these trig ratios, what are we doing? Well, we're drawing the angle out. Then we draw a triangle out from the x-axis. We need to figure out what angle is inside the triangle here. And then we just use a special triangle to find the trig ratio.